Alrighty. So, it is now 8:30. Can I have everyone's attention? It is now 8:30. Who is excited for some statics today? No? It's going to be fun. We're going to get out at 10:30, and then you're going to go home and go to bed after you make some ramen noodles. So I'm Kirsten. I've been your SI leader this semester. Maybe you see me, maybe you haven't. I always went to the evening section and sit there. Since this is recorded, I probably won't be able to answer any questions you have until the very end, just because people at home won't be able to really hear it. But if you have questions, just come at the end and I'll answer them for you. You can find my review on the UCF Study Union website, which is just ucfstudyunion.wordpress.com. And that's what I'm going to be doing today. So with that, I'm actually going to start at the end of that review. If I can flip this page. And I'm going to be doing this problem. So it says, determine the moment of inertia for the beam's cross-sectional area about the y-axis. So we know right off the bat, we have to find what our IY is going to be. Does anyone know the equation that we're going to use? Okay, good. So we know that our equation that we're going to use is going to be the sum of all of our IYs plus the sum of our A dx squared. So after I figure out which equation I'm going to use, I like to just draw it in 2D because 3D looks kind of scary and I don't want to be scared on my final. So, and if you can't see anything, just let me know. So, oh gosh. So we know this distance is going to be 8 inches. Also, my drawings are not going to be nearly as pretty as Dr. Medeiros'. We know this is going to be 1 inch. This is going to be 3 inches. And then 1 inch. And the width at the bottom is also 1 inch. Okay. So from there, we're just going to make our table. So we always know, first thing, figure out which equation we want to use at the end. 2, draw in 2D so we can see it simpler. 3, we can probably cut this up into smaller bits. So I'm just going to cut this up. This little tiny square is going to be our 1. The one at the bottom is 2, and then the one over here is going to be 3. So, I'm going to move down. So for our sections, so you know our height is 2 inches and the width is going to be 1 inch. For our section 1, we know for section 2, it's going to be 10 inches. I'm going to change markers. 10 inches. And it's going to be 1 inch high. It's going to be section 2. And then for 3, it will be 7 inches tall, and again, 1 inch thick. I'll move it up when we get there. Okay. So there's our sections. So next, we can find our area for each of our sections. So our area for the first section is just base times height, so our area is going to end up being 2 inches squared. For our second section, it's going to be 10 times 1, so our area is just going to be 10 inches squared. And then for our third, it's just going to be 7 times 1, so our area is just going to be 7 inches squared. Fun rectangles. Okay, so now we have to find our dx. And our dx is the distance of the centroid to the y-axis. So for a rectangle, we know is going to be whatever our distance is divided by 2. So for the case of number 1, it's just going to be 1 divided by 2, or 0.5. Now for section 2, we do the same thing since it's also a rectangle, and we're going to get 10 divided by 2, which equals 5. And then again, for the last one, it's going to be 1 over 2, which is going to be 0.5 inches. So far we found our area and we found our dx. So the only thing left that we have to find is our IY. Does anyone know the equation for IY for a rectangle? BH cubed over 12? That's a good equation to put on your formula sheet. But for this case, it's going to be, whenever we're taking about y, it's going to be hb cubed over 12. So a way I like to think about it is whenever you're doing y, you already have an h, so you need to cube the base. And for x, the height is cubed, but not the base. But you can always write it on your formula sheet. So once you plug all of our numbers in, we have 2, we have 1 cubed over 12. So our IY for this section is going to be 0.16666 inches to the 4th. Now we do the same equation for the next section. So it's going to be hb cubed over 12. And we will have 1 times 10 cubed over 12. And that's going to equal 83.33333 inches to the 4th. Because he always likes you to keep it to 5 sig figs until the very end. And then you can round it to 3. And now for the last one, we have hb cubed again since it's a rectangle. And we have 7 times 1 cubed over 12. And then that is going to equal 0.58333 inches to the 4th. So now we have all the components that we need for our IY equation. Oh. Is everyone good? Any scribbles? Okay. Yeah. So what might some other equations be helpful? What am I saying? What might, oh God, wait for it. What other equations might be helpful on your formula sheet for moment of inertia? That's what I'm trying to say. For the triangle and the circle? So, are you good? Okay. I'll come back to that. So we have IY. Now we have to do the sum of all of our IYs. So we have to add up our 0.16666 plus our 83.3333, plus our 0.58333. And then add that. To our 2 times 0.5 squared plus 10 times 5 squared plus 7 times 9.5 squared. And after you do all the algebra, your final answer is going to be IY is equal to 966 inches to the 4th. So some other equations that might be helpful. So we know the moment of inertia for a triangle is I can pick this piece of paper up. Does anyone know what the moment of inertia for a triangle is? Height times base cubed divided by 36. I think it's this one. The 9.5? Oh, my bad. So for section 3, it's 1/2, and then we have to add in the distance 9, because we have to bring it to the x-axis. My bad. So again, for section 3, it should be, the dx should be 1/2 plus the 9, because you have to bring it from the y-axis. Okay, everyone good? Well, technically they don't give us our z direction, so we only have the information in x and y, so we can't do it in 3D. You'll usually do 3D in dynamics, and this is statics. So, huh? Yeah. Huh? Because, let me fast. So like our centroid is a centroid from like over here, and we need it from our y-axis, because the definition of dx is the distance of the centroid to the y-axis. So like we know it from just like this rectangle, but we need to add in that 9 that we're missing. Okay. So now I'm going to move on to this problem, and it just says draw the shear moment diagram for the following picture. Okay. So what should our first step be whenever we see a beam? Free body diagram. So free body diagram. So we know we have a beam. We know we have the 20 kips over here, 20 kips over here. We know that we have an AY at our roller, and we know we have a BY at our pin and a BX at our pin. Why does a pin have 2 reaction forces but a roller only has 1? So wherever there's resistance, there's going to be a reaction. So for a roller, it's free to move in the x direction, but it can't move in the y direction. So there's resistance in the y direction, hence there's a reaction. And for a pin, you can't move in the x direction or the y direction, so there's a reaction in the x and the y. So like just in case you like get something that you don't know, if you can think about how it might move, then you can probably figure out what reactions it has. And then last, we just have our distributed load, and we know it acts in the middle. And in order to find what our resultant force is from our distributed load, we just do our 4 kip feet times our 30 feet, and that's going to give us 120 kips. So now, if we do our global equilibrium, and we do the sum of our forces in the x direction, we know that our Bx is equal to 0. If we do our sum of the forces in the y direction, assuming that positive is going upwards, we have our 2 20 kip forces, we have our 120 going down, and then we have our AY going upwards and our BY going upwards, all equal to 0. but we have two unknowns and it's only in one equation. So that means we have to find another equation. So in order to do that, we'll just take the moment about point A, assuming that counterclockwise is positive. Yeah. So taking our 20 kip force, we know that our perpendicular distance from A is 15 feet, and that it creates a counterclockwise moment. Now we have our 120, and looking at A, it makes it go in a clockwise direction, so it's going to be negative. And that its perpendicular distance is also going to be 15. And then we have our other 20 kip force, and its perpendicular distance is going to be 45 because we have the 30 and the 15. And then finally we have our BY that creates a positive moment and has a perpendicular distance of 30. So a thing to do if you don't like doing moments, I always pretend, okay, I'm point A. On the left I have my 20 kip force and it's pushing my arms downwards, so it's going to create a counterclockwise moment.
Yeah, shouldn't the other 20 be 45?
Oh yeah, I said 45. So this 20 should be 45. But just in case you can't do right hand rule or you don't like it, I just use my arms. I look crazy, but I enjoy it. Okay. My little trick. So if you pretend like, okay, I'm AY, and I have my arms out, the 20 kip force on the left is pushing my left arm downwards. So it's pushing my arms in a counterclockwise manner. Yeah, it's pushing my arms in a counterclockwise way. So like if you look at the 20 kip on the right side, it's pushing my arms clockwise. Yeah. What do you? Oh, just come to me after. Come to me after. Okay. So we found our global equilibrium. So now we can start our shear and moment diagram. So for our shear, I don't like to think about, for problems like these, it is very simple to just look at it and be able to see the diagram. So on the Study Union site, I have a worksheet, or not a worksheet, it's kind of like a sheet with relationships that you can see, and for every single problem like this, you will be able to know immediately what the graph is going to look like. So in this case, you can see that there's a 20 kip force acting downwards. So right off the bat, we know that we're going to start at 0, but it's going to go down 20 kips. And from there, it's going to stay constant the entire way to our distributed load. But before we do that, we need to do where we have point discontinuities, which is going to be at our A and at our B. And then I always put one at the end. Okay. So we know the 20 kip makes it go, our shear go downwards, and then it stays constant until we get to our distributed load. At A, we have a force acting upwards. Oh, we never finished solving. I'm going crazy. Okay, so we found what our BY was, and our BY was 80 kip. And plugging them back into our sum of forces in the Y. Huh? I have 80. And then plugging that back in, our AY is also 80 kip. Okay, now we can go to our shear moment. So like I was saying, at a point source, it's going to go down or up that much. So here, we have our 20 kips going downwards at the end. So it's going to go down 20 kips. And from there, there's nothing else affecting it until A, so it's going to stay constant until A. But at A, we have our reaction, and that reaction is 80 kips going upwards. So we know this is going to jump from negative 20 all the way up to positive 60. You don't have to do it. There's multiple ways you can do these.
What do you take points off if we want showing?
It depends.
Odds are, like, is the partial credit or going after?
Okay. So we know that our loading is related to our shear. Oh, yeah. We know that our loading is related to our shear because our shear is equal to the integral of our loading. So if we look at our loading here, our loading is constant all the way throughout. So whenever you take the integral of a constant, it's just going to be a linear function. And since it's pointing downwards, it's going to go from 60 kips all the way through the equation. So we know that our y is going to be equal to a negative 4. Yeah. I don't like this. Okay. So our function is going to be equal to negative 4x plus 60. Because we know that the height of the constant of our distributed load is 4 kips. So that's going to be our slope after we integrate, and it has to be plus a constant, which in this case is a 60 that we found from the reaction going up from our negative 20. So since we know what our equation is,
So you're saying because at A it was an 80 kip reaction and it was at negative 20 previously, that brings it up?
it brings it up to 60. So negative 4x, it goes down to 60. So after that, we're at B, and B also has a positive 80 kip force going upwards. So it's going to go back up to 20. And then stay constant until the end. And then at the end, we have our 20 kip force acting downwards, so it's going to bring us back to 0 for our shear. Yeah. It won't let me zoom out. Yeah.
You meant like, can it leave and just like adjust it up?
No.
Can you explain how you got like
So what I did is the equation for our distributed load would just be like y equals 4. So that is technically like our Wx function. And we know that our Vx is equal to the integral of our Wx function. So in this case, it's going to be the integral of 4 dx, which is going to give us 4x plus a constant. And we know that our constant is going to be 60 because we found that earlier. You always want it to end in 0. If it doesn't end in 0, then you probably did something wrong.
That means it's not static.
Yeah, it's not static then. Okay. So, going to the moment diagram. Okay. So we know that our shear is related to our moment equation. And just following what we've done before, your moment equation is equal to the integral of our shear equation. Does that make sense? It's just an integral and then an integral. So we know here it's just constant. So it's going to end up being a linear function once we take the integral of it. So if we just take the area of our square here, I'll call it 1. The area of our first square is going to be negative 20 times 15. And that is going to give us negative 300 feet, which is where our function is going to end on that breakpoint. So we'll start at 0, and then we'll go down to 300. Now for section 2, you can do the same exact thing. So we know that we have a triangle here. This is our section 2. So the area of that triangle is just going to be 1/2 the base, which we can find because we just plug in y to be equal to 0 into our equation there. So we find that x equals 15 whenever y equals 0. So 1/2 our base, which is 15, times our height, which is 60. We get that the area is equal to 450 kip feet. So we start here at negative 300, and we know that we are going to end 450 above where we started. So we know we have 450, and we want to add that to our negative 300. So we're going to end at positive 100 kip feet. Now just looking at the triangle, there's I'm not sure what you call it, but you can draw a circle up here to show what the concavity is going to be. And it's always, please don't neglect infants, neglect dumb people instead. So in order to find what the concavity of our moment diagram is going to be, you look at your shear area, and in this case it's positive and it's decreasing. So we know that it's going to look like this section right here, because the PD is going to stand for positive decreasing. The NI is going to be negative increasing. The ND is negative decreasing, and then the PI is going to be positive increasing. So like if you look at the area of our shear, it's positive and it's decreasing. So it's going to look like that side of the circle right there until our height.
What did you say for that?
It's please don't neglect infants, neglect dumb people instead. I didn't make it up, someone else did. Okay. So again, for our triangle here, for 3, we take our area, and it's going to be negative 60 times 1/2 times 15, which will just give us a negative 450. So then we add the negative 450 plus our 150, and we know it's going to end at negative 300 kip feet. So our moment is going to go from our 150 up here down back to 300, negative 300. And then again, do the same thing that we did before, the area of our shear for our rectangle here. It's just going to be 20 times 15 which is going to be 300 kip feet. Oh yeah. So we know that our area is going to be 20 times 15, which is going to be a 300 kip feet. So we are starting at negative 300, adding what we got for our area, which is just plain 300, and that's going to equal 0. So we know that our shear is going to end at 0, and it's going to be a linear function since our shear diagram is constant. And we found that our maximum takes place whenever x equals 15. Because of the first derivative test, you find where the derivative is equal to 0, and that's where its maximum or minimum starts. Okay.
So like inherently, you saw the shear cross over the x-axis at a certain point. You know that's like where a maximum is going to
Yeah,
be.
so if you ever see the shear go over the x-axis at a point that isn't like a break point, you know that there's going to be a maximum or minimum there.
Okay.
You can do this like multiple ways. This is just the way that I showed it, just in case you don't like doing all the math. This is just the way you can like see the areas and relate it together.
Is it x is 15 if A is the origin? Or if the origin is...
If the origin is like, if the origin is over here.
Shouldn't it be like 45? But I don't know what's happening with this 30.
Yeah, it should be 45. So it should be like the 15 plus 15.
Well, 30.
It'll act between A and B. Yeah. Okay. So, going back to the very beginning now. I try to make multiple choice questions. If they're awful, I apologize.
It seemed like there was a bunch where it was none of the above.
Yeah.
Like,
So.
I was really confused. I thought I was doing them wrong.
So I try to make my multiple choice questions like he has made his previous exams like last semester. So for a bunch of it, it was always like A was a number, B was a number, C was none of the above. And that's what I tried to do for most of these, just because that's what he liked to do. Yeah. So. So for problems like these, I would recommend if you just have a random picture on the page, try and read each of the problems first before just diving into it to see what you are going to have to find at the very end, to see if any of it relates. So in this case, we know we have to find our fx, our f1x. We know that we're going to have to find our f2x, or f2y. It says that we want to find our f3x. And I want you to determine the magnitude of the resultant force. And I want you to find the direction of our resultant force. So if we know that our end result is going to be finding the magnitude of our resultant force, what equation should we have on the top of our mind? Say that one more time. So yeah, the square root of the sum of the forces in the x squared plus the sum of the forces in the y squared, all under the square root. So let's just dive into all of it. So at F1, if we do F1x, we only have the 900 newtons going in the positive x direction. So it's just going to be 900 newtons. Our F1y, there is none, so it's just going to be 0 newtons. So if we're looking at our first question here, we have a 900 newtons, so our answer is going to be B. I'm not kidding you, this is literally how some of his questions were. Yeah. So for F2, if we're finding F2x, if we're finding F2x, we know that's going to be 750, and we want to make it go into the x-axis, so we're going to use cosine of 45 degrees, and that is going to equal 530.33 newtons. Now for our F2y, it's going to be 750 sine of 45. Good job. Which is going to be also 530.33 newtons. Now for F3x, oh yeah. So we found what our F2 x and y were. So what can we determine is the answer for our y component of F2? A, B, or C? A. So F3x, if we're looking at the thing, it's going to go in the positive x direction, and it's going to be 650 times 4 over 5, which is going to end up giving us 520 newtons. You can either leave it in the 4 over 5 or you can find the angle. It's really just up to you. So finding F3y, it's going in the negative y direction, so it's going to be negative 650, and then it's going to be 3 over 5. And that will give us a negative 390 newtons. So looking over to our number 3, it asked us to find the x component of F3. So would our answer be A, B, or C? C? I didn't read this very well, so I have A as my solutions, but you could probably do C since he did choose the best answer. I'm saying just choose A because I'm just dumb and I made this at 1. Okay. I'm gonna say A.
Well, you're saying C is correct as well?
Technically, because I messed up and I put 520.06.
What if that was the case on the exam? What would you do?
So that's a good question. So he always has his sig figs rule to be 5 sig figs throughout, and then he says 3 at the end. So in this case, like this one would probably, in this case, C would probably be the better answer.
More than likely,
He probably wouldn't do this, I just goofed. So for determining the resultant force, we'll use our equation that we got earlier, which is just the square root of the sum of our fx plus the sum of our fy squared. Oh yeah, sorry. I'm used to this showing the entire piece of paper. Okay. So if we plug in our numbers there, we end up getting that our FR is going to be 1,955.4 newtons. I can't say numbers. Okay. So if we're looking at our answer choices, we see that the correct answer is B. And now in order to find the direction of the resultant force, I just kind of had this memorized in my head, but theta is equal to the tan inverse of like the sum of the forces of the y over the sum of the forces in the x. It's just been drilled into there. Another way you can think about it is like if there's a triangle, you have theta here, you have adjacent, opposite, and hypotenuse. This is also like x, y, and whatever. You know that tangent is equal, like tan theta is equal to opposite over adjacent. So in order to do the tan inverse, it would just be y over x. So in order to find theta, we find that it is equal to 4.118 degrees, which is B in this case.
Number 3 was because your arrow is pointing down to the
Positive,
right, so
right,
to the
X
positive
direction.
X direction. Like if you go to the diagram, your force is in the X direction.
Yeah.
Arrow.
Yeah.
Yeah. So that's why it's not negative. Because you said you can answer none of the above.
No, I was saying because I have the 0.06, that could be none of the above, because I goofed. It happens. It's all good. Okay. So does this make sense? If you see this on the test, be happy. You know how to do this. You've done this since Physics 1. You got this. Okay. Now to our fun. Yeah, traffic lights. Traffic lights. I tried to find a picture that looks scary because his pictures scared me whenever I saw them. Okay. So we see this. What's our first step? No crying. It starts with an F and ends with a D. Free body diagram. If my free body diagram is ugly, you cannot be mad at me. So there's our Z. Our X, and then our Y. Okay. So I'll do this in a different color. We know if we're looking at our picture that we have FAC going in this kind of direction. We have FAB going in this direction. FAC, FAB. We have FAD going in this direction. And then the problem initially tells us that we have to assume that h equals 4, so the height of our lamppost here is going to be 4, and that the traffic light has a mass of 15 kilonewtons. So we know that our light is equal to 15, and in order to make that a force, we multiply it by gravity. So we know that this is going to be the weight going downwards in the z direction. In this case, W is equal to 15 times 9.81, which is equal to a number that is 147.15. Okay. So we have our free body diagram. We know now that we're going to read our questions and see what we have to find. So it asks us to find the tension required to support this traffic light in AB, tension required to support traffic light in AC, and the tension required to support the traffic light in cable AD. So we know that we have to find the tensions in each of those cables. So what I like to do is I know that I'm trying to find forces, so I don't know what the forces are, so I'm going to have a vector. In order to find a force vector, I need a unit vector, which means I need a position vector, which means I need the points. So I'm going to write down the points. So O is going to be 0, 0, 0. A, can you still see? A is going to be 0, 0, 4. B is going to be 3, 4, 4. C is going to be -6, -3, and 6. And then D is going to be 4, -3, and -4. So now we have to find all of our position vectors.
Why is the C -4 for D?
Because, that's a great question.
It's like it's like up from the ground.
I don't know. I'll just keep going, and if it's, I'll look at it later and I'll post whatever's correct on there. I don't know. Okay. So for R, we have RAB, which is going to be 3, 4, 0. We have RAC, which is going to be -6, -3, and 2. And then we have RAD. Yeah. Which is going to be 4, -3, and 0. So now we know what our position vectors are. We know that F, we have to find our force vectors now. And we know that the equation for a force vector is the magnitude of the force multiplied by its unit vector. So in that case, we know FAB is equal to the magnitude of FAB times its unit vector, which is 3, 4, 0, divided by its magnitude, which is going to be 5. For FAC, it's going to be -6, -3, and 2, all over 7. And then for FAD, it's going to be FAD for -3 and 0, all divided by 5. And then we also have the force vector from our weight, which is the 147.15 pounds, acting in the negative K direction. Okay. So now we know what our force vectors are, so we can use those in our equilibrium equations. Four, 3, 4. I'll look at it later, like I said.
Oh wait, no, I mean you go.
Okay, so we know that the sum of all of our forces equals, what is it? Our FAB vector plus our FAC vector plus our FAD vector. So from there, you can just put like the sum of the forces in the x all equal to 0 and do each of your I components. Oh yeah, sorry. You do again for your sum of the forces in the y all equal to 0, and you do all of your j components. And then you do that again for the sum of the forces in the z all equal to 0, and you do all of your I components. And then you would solve for FAC. but since I'm not sure if this is right, I'll post whatever is correct on the thing. That's right?
It ends up not mattering.
Okay. So I'll continue then. So we know that our sum of the forces in the x is going to be 3 over 5 FAB minus 6 over 7 FAC plus 4 over 5 FAD, all equal to 0. For the sum of the forces in the y, we have 4 over 5 FAB minus 3 over 7 FAC, and we have negative 3 over 5 FAD, all equal to 0. And then finally for z, we have 2 over 7 FAC minus the weight, which is 147.15, all equal to 0. So from there, we can first solve for our FAC, which is going to be 515 newtons. Then you can plug that into either your y or x, solve for either FAD or FAB, and then plug that number into your first equation. So after that, you would just have your FAB is equal to 441 newtons, and then your FAD is equal to 221 newtons. Huh? Yeah. Huh? Oh, what was the weight of the mass? It was 14 kilograms. Okay. So if we look at our questions, it said the tension required to support the traffic light in cable AB. We found cable AB to be 441 newtons. So what is our answer? None of the above. For AC, we found that it is 515. So in that case, it would be B. And then for cable AD, we found that it was 221, so that it is going to be A. Okay. In case you forgot what these were, this is a couple moment. They still exist. Couple moments are fun. If you see couple moments, you should be happy. So can anyone tell me what the equation that we're going to use? R cross F. And if we do R cross F, is that going to give us a vector or a scalar? A vector. When do we get a scalar? Whenever you do the dot product. So, for the first one, it said, express the moment of the couple acting on the pipe in Cartesian form. What is the magnitude of the couple moment? Take F to be equal to 125 newtons. And then 10, if the couple moment acting on the pipe has a magnitude of 300 newton meters, determine the magnitude F of the forces applied to the wrenches. So are any of these, do we want to do any of these first? Do we want to do 9 first or 10 first, or don't really care? Don't really care. Do 10 first? I can do 10 first. Okay. So I'm just going to go up here. I'm just going to write first that point A is located at 0.6, negative 0.15, and then 0 meters, because I converted out of millimeters. Yeah, we're going to do 10. And then B is going to be at 0.8,
0.15, and then 0 meters. So I'll keep 10 in the picture. So we were told earlier that our moment is equal to R cross F. In this case, I would recommend having R be the position vector AB. So R is going to be the 0.8, 0.15, 0, minus 0.6, negative 0.15, 0, which is going to give us the vector 0.2, 0.3, and then 0 meters. So that's going to be the position vector between our two forces here. Okay. So for problem 10, I would just have F be equal, we'll have it be the F over at B. So we know that our force vector is going to be 0 in the X, 0 in the Y, and then it's going to be a positive F in the Z direction.
If you did it on the other side, it would be negative.
If you did it on the other side, it would be negative F. So now putting that all into our moment equation, yeah. We have 0.2, 0.3, and then 0 crossed with our 0, 0, F. So just in case someone doesn't know how to do it, I'll set up the matrices. We have 0.2, 0.3, and then 0, and then we have our 0, 0, F. So first we have our I component. So we have 0.3 F minus 0. We have our negative J times 0.2 F minus 0. And we have our positive K times 0. And that's going to be Newton meters. So we know that this is going to be 0.3 F, negative 0.2 F, and then 0. So now we do the magnitude of our moment, which we know is equal to 300. And the equation is the exact same that we used for our resultant force. So in that case, it's just going to be our 0.3 F squared plus our negative 0.2 F squared, all under the square root. So after you redistribute the square and the square root, you'll have 300 is equal to 0.36056 F. In which case you find that F is equal to 832 Newton meters. No, newtons. Though I have everyone. Does that make sense? So if we look at 10, we found that our F equals 832, so our answer would be D. And since we did 10 first, for the first problem it says find the magnitude of the couple moment whenever F equals 125. So in that case, you would just redo your matrices, but have F equal 125. And in that case, the magnitude of your couple moment is going to equal, you can't see it. The magnitude of your couple moment is going to equal 45.1 newton meters.
So the question asks for the Cartesian.
That is the Cartesian form.
I think it asks for the vector in terms of the magnitude. Like for number 9, if you scroll up, like can you move it up?
I got it from the book.
Yeah, Cartesian vector.
Okay, so if we want it in the vector form, we would just have to plug in what f is here.
But if it asks for the magnitude,
If it asks for the magnitude, then you just solve for the magnitude. But if you wanted to find like what the vector of it would be 37.5, negative 25, and 0. Yeah. Yeah. So again, number 9, express the moment of the couple acting on the pipe in Cartesian form. What is the magnitude of the couple moment? What is the time? Okay. So I'm going to move on. Everyone should be able to do this problem. You've seen so many trusses by now, you should be tired of seeing them and you see them in your nightmares. So what should our first step be whenever we see any truss?
external reactions.
External reactions? What do we have to do before we find free body diagram? I would not be surprised if he asked you to draw the free body diagram even though it is a multiple choice test.
You did say there was 2 free responses.
Yeah, there are 2 free responses on it. So we have our 5 kilonewton, we have our 6 kilonewton, and then we have our
we know for a fact and are confident that it should be -5 and not +5. Now we can do the sum of forces in y. Assuming the positive is going upwards. We have our AY going up. We have a -6, a -8, and then we have a positive BY. We have two unknowns, so we can't solve it yet, so we can go and take a moment about A. Does everyone know when we take a moment about A? So since for our simple forces in the y direction, we have two unknowns, which is AY and BY. We have two unknowns but only one equation, so we need to make another equation so we can solve for either BY or AY. So in this case, I chose to take a little about AY because it would cancel out both of our AY and our AX. Because it goes through the line of action. So if you have trouble drawing the line of action, what I like to do is I'll draw kind of like a dotted line. So what I like to do is I'll draw dotted lines where the perpendicular distance at A would be 0. So I'll draw it kind of like an XY axis. So in this case, you can see that the perpendicular distance for AY is 0, and the perpendicular distance for AX is also equal to 0.
So, but looking at the 6, we know that 6 has a perpendicular distance of 2. Oh, you can't see me now. Okay. If you look at the 6, it has a perpendicular distance from 2 from point A.
So from A, would that be negative?
So if we're taking the moment about A, and you're thinking that I'm point A, the 6 is pushing my right arm downwards, making it go in a clockwise motion. And clockwise, we have as negative. Now, looking at the 8 kilonewtons, we see that its perpendicular distance from A is going to be 2 plus 2, which is 4. And again, it's going to make it go in a clockwise direction from A. So it will be negative. For BY, we have that it has a perpendicular distance of 2 plus 2 plus 2, which is, why can't I add right now? 6. And it's going to create a counterclockwise moment about A, since it's going to push my arms in a counterclockwise way. So it will be positive. And we still have our 5 kilonewton force up here. So we have 5 times the perpendicular distance of 2. And that's going to make it go in a clockwise direction. And that's all going to be equal to 0. Do I have everyone? Does that all make sense? Okay. So we have that our BY value is going to be equal to 9 kilonewtons.
What did you say before?
9 kilonewtons. Oh.
See. I don't get how it's.
Okay. If we look at our number 14, we found that our y component of the reaction at B is equal to 9 kilonewtons. We have A as 9 kilonewtons, B as 5, C as none of the above, and then D as no component exists. So our BY for 14 is going to be A. So now we can plug BY back into our sum of the forces in the y direction and find that our AY value is going to be equal to 5 kilonewtons. So looking at number 12, we found that the y component of the reaction at A is going to be 5, so our answer is B. Now the only problem we have left is determine the x component of the reaction at B. So we know that B is a roller, and again, just for like the 10 millionth time, wherever there's a wherever there's resistance, resistance, it means that there's going to be a reaction. In this case, since B is like free to move in the x direction, there is no x component. So the correct answer would be D. No component exists in this direction for this type of support. But if we were saying for like A, we found a support, it does exist. Everyone good? Now, what time is it? Okay. So this problem, you can do multiple ways. You could do a method of sections, you could do method of joints, you can do whatever you want to do.
How would you do that?
Which one do I think is the fastest one? It really just depends on you. So like, this only has about like 1, 2, 3, 4, 5 points. If it has any more than this, I usually do method of sections. And in this case, it's asking us for AB, BC, CD, and DE, EA, EB, and EC. So it's almost easier just to do method of joints, just because you already have to find everything. Do you have to? No. Could you cut it? Yes. Talking about if we were to cut it, what is a rule that we have to always keep in mind whenever we make a cut through a truss like this? You have to cut it all the way through. So if method of sections, you have to cut it all the way through. What else do we have to keep in mind? How many members does it have to go through? 3. 3 members, because you have 3 equations. You can't go through 4, you can't go through 2. Probably could go through 2. Just go through 3. 3 and nothing else. Can't go through 6. 3. 3 members. And then a helpful thing to do, like looking at our truss, if we made a cut through BC, EC, and ED, which side of it would be easier to solve? The right side? Because we wouldn't have to solve for our support reactions. So let's say you get a problem and you just really are tired and you don't have to solve for the support reactions, and the problem doesn't ask for anything on that side, solve for the simpler side. So in that case, it would be the right side. So you just cut the side off, do a free body diagram of the right side, and solve for those members. But in this case, it asks for everything. So we're just going to do the free body diagram of the whole thing. So move back over. Free body diagram. So I already drew this wrong. Yeah. It's a Monday. Okay. So So B, C, A, E, and then D. And I'll do all the external in orange. So at E, we have a roller. So what kind of force do we have for E? EY. At A, we have a pin. What do we have at a pin? We have AX and AY. And then we have P over here, that the problem tells us to assume that P is equal to 8. It also tells us that this is 60 degrees and this is 60 degrees. But that doesn't really matter. So from here, we can either do global equilibrium and solve for our support reactions and then do method of joints, or you could cut it like we did up here through BC, EC, and ED and just solve for this side first and then come and do like method of joints over on the left side. It's really just up to you and what you like to do. So for what I did, I just did method of joints, just so you got in the hang of it. So let's just go. So some of the forces in the X. We're just looking at external forces. We only have our AX in the X direction. So that is going to be equal to 0. Some of the forces in the Y. We have our AY, our EY, and then our P going in the negative direction, all equal to 0. We have 2 unknowns and only 1 equation, so we need to do another equation. So let's just take the moment about A and have positive being counterclockwise.
Is that supposed to be P?
It's P is equal to 8. It says it at the top. For all problems on this page, assume that P is equal to 8. So just looking at the 8 and taking a moment about A, we know that this distance is 4, this distance is 4, and then the stop distance is 4. So we have 8 times 8, and our P force creates a counterclockwise or clockwise moment about A. Clockwise. So that means it's going to be negative. Next we have our EY, which creates a positive or negative moment about A. Positive. And its perpendicular distance is going to be 4. And then that is all going to be equal to 0. And from that, we can find that EY is going to be equal to 16 kilonewtons. We plug that back into our sum of the forces in the Y, we found that AY is equal to negative 8 kilonewtons. So from here, you could either start at A or you could start at D because they have the smallest number of unknowns. I just started at A. So for my method of joints, I started at A. You could start pretty much everywhere. You want to try and choose a place where you know the most things. So in this case, I have AY at A, and I only have 2 unknowns. At D, I know At D, I know I have the 8 kilonewtons acting downwards, and I don't know my CD or my ED. So I know I only have 2 unknowns there. At E, I have a whole bunch of unknowns, because I know EY, but I don't know EC, EB, AE, or AD. So that would be smart. And I don't know anything at C, and I don't know anything at B. So you can either go A or you can go D. Or you can just completely not even do this and do method of sections like we were talking about before. Really just up to you. So if we're doing method of joints at A, so we're going to do our free body diagram. We have AB going in this direction. We have AE going directly to the right. And we have AY going upwards. But we actually know that it's a negative AY, so it's actually going downwards.
So you're assuming AB and AE are in tension?
Yeah, I always assume everything in tension. Maybe you'll find at the end that you assumed it in tension, but it's a negative number. That just means it's in compression. I assume everything's in tension even after I find that it's negative, because if I start changing it, I will get confused. So, do the sum of the forces in the y direction, equal to 0, positive being up. And we know that this angle in between our AE and our AB is 60 degrees because it gives us that at the beginning of the problem. In the diagram, we have AB sine 60 plus AY is equal to 0. So then AB is equal to 9.24 kilonewtons. And since it's positive, that means what? It's in tension. So now we can do the sum of the forces in the x direction for our free body diagram. And we have our AB, and we are going to multiply it by cosine 60 since we need the x component, plus AE equal to 0. So we find that AE is equal to 4.62 kilonewtons in tension. Yeah.
Like, because it would be negative.
AE.
You'd have to subtract it over one side.
Yeah, I'm bad at math. It would be in compression. Okay. So looking at our answer choices, we found that AB is equal to 9.24 kilonewtons in tension. So what would our answer be for number 15? A. What about for AE? We found that it was 4.62 kilonewtons in compression.
That would be C.
It would be C, because none of the above.
Do we think there'd be that many if none of the above ones?
I took this problem from his old test, exactly. Yeah. It was like one of his, it was like test 3.
So content that would be on.
So we did our method of joints at A. So next we can go, why did I do that? We can go over to B. So again, free body diagram. So we have our AB acting downwards, We have BC going directly to the right. And we have BE. So, doing the sum of the forces in the y direction, with positive going upwards, we have negative AB sine 60 minus BE sine 60 equal to 0. So if you move it over, you have negative AB sine 60 is equal to positive BE sine 60. So the sine 60s cancel out, so you know that BE is equal to negative AB. And we found that AB is equal to 9.24, so it's actually going to be negative 9.24 kilonewtons. So that's just 9.24 in compression. Okay. So, going back through, we found our BE. So for number 20, it asks us what determined the force in member EB. And in this case, we found that it was 9.24 kilonewtons in compression. So it would be B in this case. Alright, so doing the sum of the forces in the x direction now, with positive being going to the right. We have negative AB cosine 60 plus BE cosine 60 I put in the negative number.
Oh.
So you could,
Same thing.
so I just assume everything in tension, and even though I find that the number is actually negative, I still keep it in tension, just because if I change it midway through, I always get lost and do something wrong. It's really up to you. If you think that you can handle changing it midway through, do it. I can't handle it, so I don't. Yeah, it's kind of just like a judge of character. If you know that you mess up on tiny things when you're nervous, keep it the same and just make sure that you know that it's a negative sign. You don't want to mess up on the little silly things. Okay. So we did our sum of force in the x, and we have negative AB cosine 60 plus our BE cosine 60 plus our BC all equal to 0. So in that case, we know what AB is. We can check that off. We know what our BE is. We can check that off. So now we can find what BC is. In this case, BC is equal to 9.24 kilonewtons in tension. So it is going in the direction that we assumed. So where is BC? Going to 16, we found that BC equals 9.24 kilonewtons in tension, so the answer would be A. Okay, so now going to C. You have BC going to the left. You have EC going downwards. Oh, yeah. And you have the CD going downwards. And then I just went up here and found that this angle is 30 and 30. It's just a 60, 60, 60 triangle. It's like up here, you found that this is 60 degrees. If you cut it in half, you know this is a 90-degree angle, so you can solve and find that this angle is just 30 degrees.
Could you just do the reference angle for like the horizontal thing?
Yeah, you could use a reference angle. Okay. This is C. So did I goof? Okay. Doing the sum of the forces in the y direction equal to 0, with positive going up. We have negative EC sine 30 minus CD sine 30 equal to 0. So we have two unknowns. Do we? Do we solve for CD? No, not yet. So you can either do the sum of the forces in the x direction and plug it back in, or we huh?
That's your reference angle. Wouldn't it be cosine 30 there for y? Like since it's like the adjacent.
Yeah, it should be cosine. Who would go down? Okay. So you can either do some of the forces in the x direction and plug that back into your y, or we can go over to D and solve for like CD over there. So we have CD going up, we have ED going to the left, and then we have P going downwards, that's 8. You can do sum of forces in the y direction, and you can find that CD sine 60 minus 8 equals 0. So then CD is equal to 9.24 kilonewtons in tension. If you do the sum of forces in the x there, you can find what your ED is.
So you jump to B because at C you like
Yeah.
have some missing info.
So again, we had two unknowns at C and the sum of forces in the y. So you can either do your sum of forces in the x and solve for like EC or CD and plug it back in, or you can just jump over to D and solve for CD.
Okay.
So doing sum of forces in the x at D, you have negative ED. Can you still read that, or is it hard to read it? I'll write at the top. So you have at D sum of the forces at x, just so you might be able to read it better. We have negative ED minus CD cosine 60 equal to 0. So you found that ED is equal to 4.62 kilonewtons in compression. So now, since we found what our CD is, we can plug that back into our equation for the sum of forces in the y and find that EC is equal to 9.24 kilonewtons in compression. So going back to our question, determine the force in member CD. Is it A, B, or C? We found that it was 9.24 kilonewtons in compression. So it would be B. For member DE, we found that it was 4.62 kilonewtons in compression. We have A is 9.24 kilonewtons in tension, 9.24 kilonewtons in compression, or C, none of the above. In this case, it would be C, none of the above. For EC? Yeah, EC is in compression. So So at the bottom, we found that EC is equal to 9.24 kilonewtons in compression. So for 21, we have that the answer choice is going to be B. Any questions? If we wanted to cut it and do method of sections, we would just cut it through here. You could do the free body diagram of this side and solve for CB, CE, and DE, and then go over to this side and start solving for the other ones. It's really up to you. You could probably use method of joints, or you could uncut it and make another cut over here. It would probably be a little bit more work. It's really just what you want to do. Yeah. So like if he only asks for like maybe 3, I recommend trying to do method of sections. If he asks for all of them, I would do method of joints, but if you really just love method of sections, do it, and then whatever else you want after that. Any questions? Yay, nay? Okay. Okay, what time is it? Alrighty. So yay. So what is the equation that we're going to use whenever we're trying to find a centroid for the x or a centroid for the y? X squared dA? Anyone else have a different opinion? The integral? The integral? So I'm hearing x bar equals the integral x tilde dA over the integral of dA. And for y, it would be the same except for y. So it would be y bar equals the integral of y tilde dA over the integral of dA. So for both 22 and 23, I couldn't figure out how to do the bar, so I tried my best. So I said locate the centroid x of the shaded area. So these are both like the x and y bar. Yeah. So we know our equation that we're going to use to find the centroid is going to be the integral of x tilde times dA over the integral of dA. And then for y bar, it's going to be the integral of y tilde times dA over dA. Okay. So the first thing I like to do is just define what my dA is going to be. So in this case, dA is going to be x2 minus x1 dy. With x2 being equal to a minus b over h times y plus b, and then x1 being equal to a over h times y. So if we plug that into dA, dA is equal to b minus b over h y. And then I have it as dy. So for dA, I did x2 minus x1. Because you're trying to find the area. So like if you imagine like there's a little sliver here, it's kind of like you're doing like base times height. Your base would be this x2 minus x1, because it would pretty much be like this side minus this side. And then your dy would be the height. But since it's for a function, it needs to be the differential height. So that's why it's dy. And you kind of like solve for the x2 and the xy by just looking at these equations. So like here would be your y1 and here would be your y2. And you just solved it in terms of x. Which is why it became like ab over h times y plus b. Because here y2 equals h over a minus b times the quantity of x minus b. It's flip-flopped. Okay. So, does anyone have an idea what our x tilde would be? Anything? Our x tilde equals x1 plus x2 minus x1 divided by 2, which is equal to a over h y minus b over 2hy plus b over 2.
Just like floating tuition. When did you do that?
Yeah,
But it's kind of like an oblong shape, so it's
yeah, it's a very odd shape. In my solution, I'll put like a little sticky note and like explain why it's this. Just because I'm bad with thinking of words on the spot sometimes. Okay, so our x tilde equals this. So x bar equals, again, the integral of x tilde dA divided by the integral of dA. So if we plug that in, it's going to be the integral evaluated from 0 to h of a over hy minus b over 2hy plus b over 2 times b minus b over hy. Yeah. Thank you. dy divided by the integral from 0 to h of b minus b over hy dy. And now you just evaluate the integral, but we're running out of time. So our x bar is going to be equal to xb over 6 times a plus b over bh over 2. So it's going to be equal to 1 over 3 a plus b. Yeah?
The x tilde right there.
Yeah.
I think I kind of just realized it. So like the x2 minus x1
Mhm.
is a rectangle.
Yeah.
It's like half of the rectangle.
Mhm.
It's the centroid there. But you have to add that to the distance
Yeah.
from the y, and that's what x1
So
is.
the x tilde is like, you said it's like the, yeah.
It's the centroid of the differential rectangle.
It's the centroid of the differential rectangle. So you kind of have to like find the center of that and then account for its like displacement. So we found that our x bar is equal to 1/3 a plus b. So if we look over at our answer choices, we see that our answer is going to be D. I don't know if you would ask this as like multiple choice or if you would have a problem like this be your free response. Yeah. Yeah. I know he really likes to use Simpson's rule, and there's a problem in your optional homework that actually has you do a problem like this and then use Simpson's rule in it. So I would, on your own time, try and find that. It's in like chapter 10 or 9.
Doing the integral here, you would do Simpson's rule.
I'm just saying, like, I know he loves Simpson's rule, so there is a problem in the book that uses that rule that he might try and put on your test. Okay. So now for 23, we have y bar, and again, just rewriting our equation down here. So the integral from y tilde dA divided by the integral of dA. In this case, our y tilde is just y, and our dA is the same thing as above. So it would just be b minus b over hy dy. So plugging that into our equation down here, we have the integral evaluated from 0 to h of y times b minus b over hy dy, all divided by the integral of dy, or dA. So y is actually much simpler than x. If you just look at the two integrals, this one's a lot easier. That one's a lot more work.
Why is the y tilde just y?
Because like the y is changing. So like no matter what, it's going to be differentiable, but for like the x, you had to find what the x distance is going to be at any point. But since we're evaluating the integral, we already are finding it at any y distance because we're using the y bounds and the dy. So just evaluating the integral, we have bh squared over 6 divided by bh over 2, and that is going to be equal to h over 3, which is a lot simpler than 1/3 a plus b. So for 23, we have that the answer is going to be b. And I think that is now the end, yeah. So, oh, sorry. Up. There. Oh, sorry. So thinking about your formula sheet, what are some helpful things that you might want to put on there? Everything. Should you put down like word for word problems? Will those help you? I would recommend just writing down. Is it okay if I cover this now? I would recommend like writing down like the methodology. So like your steps for like different types of problems. On the Study Union WordPress site, I have a document with all of the different equations for the centroids and moment of inertia that you might really want to put on there because it has nice drawn diagrams too, so you won't be confused by your own handwriting.
Do you know if this notion is front and back?
I don't know. It is. So someone said that the formula sheet is front and back. It's on, I'll write it down. It's on the UCF Study Union .wordpress.com. You can find that. You can find this review, and then you can find another thing that has kind of like relationships for shear moment diagrams. So methodology, make sure you have the moment of inertia equations. Make sure you have like parallel axis theorem just in case you like blank out. I would make sure that you know how to take like the centroid of non-area shapes. So like whenever it might be, like it might be a triangle. I know he had a problem in the homework where it said that it was a wire, so you had to use like, it was like the sum of XL over the sum of the L. That's a really interesting problem. That might be like a good practice. Like problems that make you use like the sum of the blah blah blah, where you have to use a chart. I'm trying to think. It's really just
You guys are gonna do great. Don't worry about it. If you guys start to get tired, don't stay up all night and get some sleep. And don't drink too much coffee, because you will get really tired of it and build up a resistance. But good luck. Yeah.